ascertain what is needed to develop the moon and make it commercially viable, or make it scientifically sound, or give us security. There are some people who think that you can establish certain tracking stations capabilities on the moon that could become superior to those that we have in orbit because of the size of the moon and anyway, it gets pretty way beyond my clearances, but some people do think that it has some security aspect. We can certainly do radio telescopes on the backside. We can establish that kind of communication. Now, what do we do for orbit to orbit? Okay, let's look at the requirement of long-term life support, high reliability, and volume for these people, however many there are, that are going to be traveling. Let's say we got a big spacecraft that'll do the task. Let's compare that with two that are half that size, medium size instead of large. That gives us a little bit of advantage, because if one of them is unavailable, hopefully there aren't single-string failures on both of them. If one of them is not available, we've got the other one. Now let's take those two medium size and do what engineers do, and do a little train study. Make one of them smaller and the other one bigger. And pretty soon, the small one disappears. It goes to zero. And we're back where we started from. But somewhere in that combination is something that is really good at either Mars or back at Earth. Maybe a small and a medium large. Well, we're already building small. It's called Orion. Let's just change what it does to be a small. And it's reusable. It'll come back and aero capture, but not re-enter the atmosphere. And the other medium large. Now, when you get to one planet or the other, the small one can take the crew to different orbits without using as much fuel. The larger one can be a habitat at different places. We're already building one called Orion. Let's have an exploration module, but let's have a test bed of what's going to go in that and put it up at the space station in 4 or 5 years. We're going to keep flying the space station till 2020 or beyond. And we test different equipment on there. We'll use the electric power from the space station, use the radiators. And if we put a little sustainability on this test bed, and its prototype that follows that, a little bit more operational, lo and behold, if something goes wrong with the space station, we just separate this thing. It becomes a safe haven. And we don't need as many lifeboats at the space station. That may be an additional thing. Once we get that operational, we can begin to check it out in Earth orbit with the two reusable spacecraft. Then together, we can send them cycling back and forth between Earth and the moon, testing them out in different temperature, different maneuvering conditions, and then maybe leave them at a libration point, L1 or L2, as a man-tended location for refueling. Then we can start flying by comets. And as we fly by a comet, the upper stage will guide it to crash into the comet. Just imagine, we prop the Earth and everybody here to realize what the mission is going to be. They can see the comet with its little tail. Everybody's got the binoculars out. And they will see the big burp when the upper stage crashes into it. They'll be talking to the crew and watching the TV coming down to see what the crew is doing. We involve the public in all these missions, cycling back and forth between Earth and the moon. That's a great tourism mission. It's not too good if your purpose is to land on the moon, but it's a forerunner of cycling spacecraft between Earth and Mars that can deliver people without having to stop as it swings by Mars or stop when it swings by the Earth. Have you ever heard of
not invented here. Yeah, well, I discovered those orbits in 1985, 25 years ago, and it still is not being incorporated into any NASA design reference mission. Neither are specialized spacecraft, one to orbit, from orbit to orbit. Sure, they got a lander when you get there. It's got to be a little different. But a lot of them look like command modules, as if they just landed. Now they're going to lift off, come all the way back to Earth, and land in the ocean again. So, no design reference mission uses two, small and medium large, specialized. They don't use a cycling spaceship for the one-way trip of dropping people off. And they don't use the moon Phobos. They just go straight to Mars and land. That's why we're in the big fix that we're in now. And guess what? The Congress wants NASA to build a heavy lift vehicle right now. You know why? So it'll have solid rockets on it. So the people in Utah can continue working on solid rockets, which we don't want. Or I certainly don't want them. And they want to keep Orion taking the crew, making it a multi-purpose spacecraft. And they are telling NASA what to do. Congress. Since when did they become engineers and future mission planners? People are not going to like it when I start talking about what made Apollo work and the crew and the booster that began this whole business of solid rockets. And then the solid rockets want to keep perpetuating what it is they're doing. And the people building the spacecraft, Orion, to go into Earth orbit, they want to compete with the commercial people. Who are the commercial people? Well, the one they talk about is the weakest link, the one that makes the most noise, SpaceX. He's flown a rocket twice, never flown a spacecraft, really. They never build a spacecraft if people are in it. You don't see the people that want to keep Orion delivering people. You don't see them criticizing the Boeing capsule patterned after Apollo that Boeing is going to commercially build and put on a Lockheed Atlas rocket. No, those things have a heritage. There's another lifting body called the HL-20. We kind of stole it from the Russians back in the 70s and 80s and put a lot of time with wind tunnel tests on this HL-20. And then set it on, after wind tunnel tests and all that, we set it up on the shelf and canceled the orbital space plane so we could go back to the Apollo days. We really have made some bad mistakes, and they want to keep propagating them. When I submitted my plan to the Augustine Commission about a year ago, I was aware of what was going on. I had heard people talking about Phobos and what it means, and so I planned this exploration module at the space station. I plan to send it back and forth to the moon, fly by comets in a one-year pre-return mission, go visit near-Earth objects, land for 30 days, then come back again, do that a couple times, even do that with Apophis. You all know what Apophis is? It's coming by inside geosynchronous orbit on Friday the 13th of April 2029. And if it goes to just the right spot, in 2036, it'll hit the Earth somewhere between northern Japan and the Panama Canal, nominally off the coast of California. 150-foot tsunami waves. Apophis probably won't do that. I mean, the odds are pretty slim, but that's something that's of great public interest. And we can fly a mission to it and demonstrate the ability to alter its path. How many of you were watching C-SPAN when I was interviewed about going to Phobos? And I said the Canadians have done a wonderful study on this. Incidentally, there was a mission planned for last October to go to Phobos. called Phobos Grunt. Well, Grunt means soil sample return. This was a complicated Russian mission, a soil sample return from the moon Phobos. It wasn't quite ready. I saw the model of it in Farnborough Air Show, I think it was. It has a Chinese payload on it to orbit Mars. And I understand that just a little bit ago, China has another mission after that in 2013 to go to Mars and set up an orbit around Mars. Anyway, this Canadian mission with a big, thick report of sending robots to Phobos and doing a lot of excavating and looking around. They had one slide that I really liked that I put in my briefing to the Augustine group. The slide showed a view of an object on Phobos that's caused a lot of attention. It's a rock that comes straight up. And the Canadians have decided to call it the monolith. Yeah, you remember 2001, don't you? Well, the slide that I showed had a couple of views of this, and the top of it said, "Where do we land?" This is the Canadian mission. Along the side, the scientists say, "Go for the monolith." That's the kind of thing that'll catch attention of the public and get them thinking about what in the world Phobos really is. In the last, let's say, 25 years, the difference between NASA flying the shuttle and the Air Force flying its rockets and science rockets and commercial rockets, it was decided we should have a national family of launch vehicles that have a degree of similarity. And so there were a number of proposals made: a national launch system, an advanced launch system, a space lifter, Space Launch Initiative, the X-33, the Delta Clipper, a whole lot of things that we're trying to unify. This is the best opportunity the nation has ever had to set aside the shuttle-derived vehicles. We don't need a heavy lift rocket right now. The President's budget said, let's really understand and start working on it in 2015, and we'll have something by the time we really need it. But we don't need it right now. With the scarcity of funds, we shouldn't be building a spacecraft competing with the private sector to do the things that we don't want it to do in the future and to build a heavy lift rocket. Who's going to make the difference? Congress. But you guys got to say something about it. You guys got to understand what it is we're about to do. And I'm trying my best to build a case for what should be said on May 25th, next May 25th. A global space doctrine, permanence on the planet Mars in 2 to 3 decades, and U.S. leadership. That's what we need. We don't need to fatten the calves of Utah and pat on the back the Marshall Space Flight Center for all the wonderful things they've been doing in the past with rockets. And when people, well, here's my mission, an opportunity to go to Mars, whatever it happens to be. Let's say 2025. Let's deposit a habitat on Phobos where we want it. Now, why Phobos? Well, let me just give you one fact. Spirit and Opportunity have been on opposite sides of Mars for 5 years. They were supposed to last about 90 days, I think. But they've been there for 5 years. The project manager of that is Steve Squires from Cornell. He has said, and put it in writing, that if we had human intelligence in orbit, close, around Mars, or somewhere where they could get direct control of those 2 robots, what they've done in 5 years could be done in 1 week. That's the power of direct control and direct doing of things on the surface. Okay, let's say we've got a habitat on the surface in 2025. Now we send a crew of 3 there for a year and a half, and then we'll bring them back. But before they go, during the launch window, as we're waiting to build it up, we put all these things in orbit, and they're waiting. And as soon as the launch window opens up, off they go, and they land at different places on Mars. And these 3 guys up there for a year and a half, they put the things together and test them out. Then they come home. Then we do that again. And maybe a 3rd time. But this time, the 3 guys have a lander. Because they finished 3 different periods of a year and a half of assembling a project far greater than the Panama Canal, the Suez Canal, the Three Gorges Dam. This is an engineering marvel of robotic assembly. We got to learn how to do that, how to build up the kind of base that we really want. And then the 3rd time, we got 3 guys there. Now we send 6 from the Earth, and now we got 9 people on Mars. They're not coming back. Astronauts, when they're selected, whether it's 2016, 18, or beyond, will realize if they are successful in their career, they will spend it the rest of their life living out being a pioneer on Mars. Just think of what the history books are going to write about these people. Just think what the history book is going to say about the world leader who commits a nation, a group of people, to do this. Far greater than what JFK did, sending a couple of people to kick up dust for a while. There was no sustainability about all of that. And obviously, we didn't keep going back and make something out of all of it. But when we go to Mars, we must. If we go there and stay for a year, year and a half, and come back, then do it again. When you do it again, you get there about 5 or 6 months after the people have left. And you get there, so it's been vacant. And you do that the 2nd time and the 3rd. I can guarantee you that earmarks or not, Congress will decide, we know how to do that, we got another place to spend our money, and everything we put into going to Mars will be wasted. That's why we must commit to permanence. We don't have to commit right this moment. We may have a leader that says that would be a great thing to do, but we can back off of that after we visit Phobos and we see what things are like, and then we decide bringing minerals back from asteroids is far better than putting humans on permanence at Mars. I don't think that'll be the answer, but I'm not volunteering. I hope I'm around to see the first people living in a cave somewhere in Phobos. I know that we've gone over our time, but I wanted to give you an idea of how we got where we are today after the principles of specialized spacecraft won us the moon and won us clear leadership. After that, we've done things that have not quite lived up to our expectations. But let's not fret about it. That's the past. Let's learn from those things we did that are not quite right and move on. We need to support that space station to test out the equipment for long-duration flights. And we need to use the moon for robots, control from Earth, or control from somebody in orbit in rehearsal for what we would do, Phobos, and controlling things on the surface of Mars. A pressing question, now that we're 50 minutes over?
Well, thanks very much.